Welcome to Houston I.O. Good day. Welcome to Houston I.O. My name is Rintsi. I work as a principal architect at Houston Inc. And today we are going to talk about how to run a GUI application inside of IoT Edge Runtime. This talk was originally a part of Finnish Azure user group tips and tricks extravaganza to the Max 2020 that is still going on. I will put the links into the description so you can find it later on. But yeah, from that first presentation, I've advanced this demo a little bit, and also I had a demo effect on the last talk. So I hope that today demo gods are more with me. But the thing that we're going to look at now is a little bit more extensive than that last time. So to set up the problem a little bit beforehand is that there was a lot of drought in Finland last summer, and my parents live in the countryside and they have a well, and it dried up. Of course, that's, you cannot make a dent to the, I don't know what's pohjavesi, but it's just to make sure that at least they know where the level of the water is, so that they can be at least then they anticipate the ending of the water from the well, that it brings a little bit of peace to them. So then, we were discussing with that my mother, and I promised to do some kind of thing to monitor the well levels there. And of course, it's a good thing to learn new technologies and so forth as well. So what I started with, as unfolding this, we ordered the hydrostatic pressure sensor from China. It has a 10 meter long cord, and it's optimized to measure the water level or the liquid level from the pressure it senses when you lower it down to the bottom. So and then that works as RS4885, so the current loop technology. So it has a 4/20 milliamp current going, and it then that can be translated to a value that it actually then does. And I have this sort of Arduino Uno and then a labeling shield that they don't sell anymore, but I was lucky to have one. I ordered it already last year, and then it has these channels that you can then listen to. But what I did in the Azure context is that I made a module with Golang that basically listens to a USB port where the Arduino is connected to, and then it reads from that and puts those values that it receives with gRPC protocol to the next module. So the actual Arduino code is here. It uses the 420 milliamp sensor board from Libelium, and there's just code that you can use it. I have my sensor in channel 1. I turn the sensor board on and I begin the serial connection. And it's just the simplest thing. I have a loop as you have in Arduino Code, and every 2 seconds I output the actual value, which is from 0 to 1023. So essentially, one unit is 1 centimeter approximately in this scenario, because the hydrostatic pressure sensor is calibrated to 10 meters. Then, just for the sake of it, I output also the voltage and the current that are coming from the device. Okay, so this is the format that is coming from the Arduino device over serial connection. So that's here in the USB port. Then we just listen to that here we make the serial and start read the connection. So we have this here that scans. When it gets a new line, it instructs the actual telemetry object. I have the function here. So we make this gRPC message. We construct this, and it just returns the object. It has the timestamps. We generate the timestamp here, and the value of this and the comment, and returns that. And then whenever we get that, we can send this message over the gRPC client to the gRPC server that we have created. Okay, fair enough. The reason why we went to gRPC at this point is that there isn't the official and up-to-date implementation of the IoT Edge module SDK for Golang. So we were pondering upon what technologies to use, but then I wanted to try gRPC, that how it would work, and it works nicely because we have type safety in the telemetry, and there's an agreement on how the interfaces work. So when you send something, what you should do is expect as a response and so forth. So there's a contract in there, so I think it's quite nice. Then when you have the server and the client, you need to share the protocol messages. So, and then I was thinking about first that that I would do this demo just with having the proto file files in each project. But I had some time yesterday and the day before yesterday, so I actually made this another repository that I can then share with this project. So with Golang, you can just import it directly from GitHub and then use this generated code that is generated from the proto file in Golang. In JavaScript that I will show next is the identity gateway. That is the server side. We can dynamically load from the proto file. So the proto file is like this. So we have this current loop service and the send telemetry function. It expects current loop request as the argument to the sending, and then it responds with this current loop response message. And this is the contract, really good, well-defined contracts that you get with protocol buffers. Okay, and then I made to this repo I made a quick abstraction that you can dynamically read the proto file and just export the actual package definition, which you can then use on the servers. So then the server implementation. So then we have my package, which is coming from npm. You can just install that, and that exports our current loop prototype or the proto package, and then it has the current loop service that we can add to the server. And then we have the implementation of what happens when the send telemetry data comes in, or when that method is called. And what I do here is I take the request, I make it a message, and then we can send that message with the module client that that this module has. So it has this module client, which is basically connecting from the edge device into IoT Hub with MQTT or AMQP. You can decide what transport protocol you want to use and give it as an argument. It might be AMQP as well. The MQTT is far more popular though. So this then automatically connects this module into IoT Hub, and then we have the gRPC server at the same module. So we get the messages in from the Arduino module with this gRPC server, and then relay those messages upstream. Cool. And then the kind of like the beef of the thing. This is then needed in order to get the data both out from the serial connection, and then from the gRPC server into this module that can then the SDKs are good with JavaScript. They are the official SDKs by Microsoft, and yeah, it's easy to use and supported. So then from this module onwards, it goes to the IoT Edge runtime ecosystem. So, and these messages, I can define these output namespaces, so you can then do routing with these messages as well. I show that a little bit later on. Okay, so then those were the two modules handling the gathering of the data from the actual sensor. And then we have the UI application, which is actually just an Electron app, essentially. But you can then package that into Docker. And by the way, we are also doing multi-architecture builds. So we can support AMD 64 and ARM 64, which I am actually running ARM 64 on my Raspberry Pi here, which is my demo device, which the application is now deployed. So and we are using BuildX to make the multi-architecture builds. It's not the complete trivial thing, but we can use the GitHub actions in order to achieve the multi-architecture builds. But to quickly go through what happens here, we just take your Ubuntu. This is also our underlying operating system. Well, actually it's 2004, but Ubuntu nonetheless. We just install Node and change the working directory. We copy the package.json. We take the version from the package.json to version text, which we can use later on, then make the version. So we we can just use package.json, which is nice. And we need to do a little bit of magic on because the architectures are stated as Linux architecture, and then the Electron packager takes one architecture and the installer takes another. It's a mess, but we can still achieve it by fiddling out a little bit with Z. Anyway, then we just rebuild our packages. If we have any packages that rely on native C modules, they need to be rebuilt for the architecture. So that's why this line is here. It's not needed on my application, but it could be needed if we would have, for example, a module that listens to audio microphone, and you could say, hey, computer, do this and that speech recognition stuff. So you would have to rebuild it for the architecture. Then we have a packager that actually packages the Electron application. And then we have a Debian installer that takes the package and makes a deb package out of that we can then install to the actual operating system. So to quickly go through from here, there are some scripts here, we rebuild, and then we have the packager. And the packager takes the architecture here. And for this, I believe that it was that way around that, yeah, the architecture is, for this purpose is that the Electron packager assumes that it's x64 if you want to build 64-bit system. So basically the AMD 64. and you don't have to do that with ARM. The packager recognizes ARM64 as the architecture, but not AMD64, and that's why we need to change the AMD to X in this context. So yeah, then we build it. It outputs the package out to dist, and then we have the Electron installer that takes that package from here and then makes an installer. And here we need to use the platform. So again, at this moment, it changes to AMD64 again. I think at this point, this is just a name for the architecture. So then if you are running Ubuntu, for example, and try to install this, if this would say x64, it just states when you try to install the Debian package that this is not unsupported architecture. So when you change on AMD64 into this, you can then install the package, no problem. All right. So this is also a multi-stage Docker file. So we are naming this this first part as a builder, and we have our last run here, building the stuff. The last thing is that I make this a little bit easier to myself, and we have this versioned package here, but I just moved that to just be the ui.deb here, so that now when we start the actual running part of the container, is that we just start a new prom, and it stops the builder part there. That we can then refer that later on. Then we just have a few dependencies that we want to use, and then we make a user that we can then use here later on, and we run this Edge application as the actual same user with these UIDs and group IDs from the host system to external security. And okay, then basically everything that we need to do is we take from the builder part from up there, we take the Debian package and we just install that. We change the user and then we run our application. Boom, done. So that's basically that. A little bit complex stuff, but I kind of, this is the accumulation of I've been doing these exercises wanting to run Electron app on top of Docker for kind of 18 months now, and now I finally have every piece of the puzzle at place. And also I wanted to run it orchestrated by the from Azure with IoT Hub. So that's now working. I'm a happy camper. All right. So I also want to quickly show you the Github workflow that we have for this. So, and after the end result, I will show later on Docker Hub. So we built these Docker images and deploy them to Docker Hub. So a few things here. When we push to master, we basically run this. I'm not sure why it's called pull request here. I think that's just the name. I'm not sure, but it basically says that whenever there's a push on master, then we built this Edge version, which is the default version here. So whenever code comes in, it automatically builds the Edge version. Also, we have a cron here scheduled for every day at 10 a.m. I think that's UTC time. And if that's the schedule event is triggered, then we put the version as a nightly version. So this will be automatic. And then finally, we have, whenever we have a version tag, so we make an actual release, then we take the version from the tags and then make the version tag and also the tag the latest in Docker Hub. Yeah, so then this prepare step just outputs all the arguments for the buildX operation. then we have this crazy GitHub action Docker build X module here, and then we defined our architecture here. So the platforms we are targeting are MD64 and ARM64. So then we just take those arguments in here, and it starts the build process. It does build also these images in parallel. So it's a nice thing, so you don't have to queue them. And also within the Docker file, it knows how to do the build part first, and then wait for the other parts when you are referring with the from to the other part. So it starts both of those builds at the same time, and then when we have the from, it waits that the first part is finished, and then it continues from the from on the latter part to make the actual then container to the end. Then we log in, we take the secrets from the Docker GitHub secrets, Docker login, and they'll then push the packages there. And this is then the hard part that BuildX has abstracted nicely with us for us, because there's a huge amount of things you need to do with the manifests that you can do these multi-architecture builds. But to quickly show you what's going on is that here's the Docker Hub, and here's the actual UI container. So you can see that we have these tags here, and this is also looking quite professional when we have multi-architecture builds, so that the architectures are shown here. Then we have the latest, which should be the same version as this. The dices are the same for the latest and this latest version 0.5.6. Then we have the Edge release. That is whenever something is pushed to master, we have this Edge, and then this is built automatically, the nightly tagged version. All right. Then this is basically everything that's going on here. We quickly go to, well, I think that we have a 30-second buffer, so it's no. I think that we take the QA then afterwards. Then I move now to the actual demo. So when you want to run this thing, then you make this deployment manifest that you tell that what kind of module do you want to run inside of the RTX runtime. So basically, when you make a new with VS Code, if you make a new IoT Edge solution, it creates these files for you automatically. And you get this deployment template, which contains these system modules by default. So it needs two things, the agent and the hub. And the agent, I believe, is you make sure that the correct modules are being run, and the hub handles the communications towards the cloud. So basically makes the MQTT connection and so forth. And here you can see that the hub supports AMQP, MQTT, and HTTPS. So here are the corresponding ports for those and the port bindings for that. But then we have these modules that we define, and basically you first give it a name, which is then reflected on the Docker runtime. Then you define your environment variables. We are using the USB 0, and then we have the gRPC address. And this is quite nice, that thing that you can do, that if you know that there's one-to-one relation between certain modules, you can refer to the internal DNS, because the modules in IoT Edge runtime are deployed into the defined internal network. So they share IP address range, but they're on the same network. So you can just refer to the name, and the internal DNS tells us what's the internal IP address of that service. So we can then know that the gRPC server is here and define the gRPC address in this module here, like so. Then we need to bind the actual device that we can actually then listen to the device and state that we have a permission, or we bind the device as well because it's a device, or define the device for Docker. You see. Then we have the identity gateway setup. We defined a couple of environment variables for that. Also, the gRPC address referring to itself now here. And here's the image that we by default coming from Docker Hub. So it's really easy when we are now making the Cerulean Data Hub modules open source. Everything is LGPL 3.0. So it's easy that we don't have to define any private registries and the credentials and stuff, because it's really a pain in the ass, to be honest. Because then you need to put the credentials here in the settings of this edge agent, and it's harder to make it secure when you have to deal with this stuff. So it's really easy now for us. Then we just expose the necessary ports and stuff for making the connections and so forth. And then finally we have the well UI. Couple of things we need to define to that module is the most important one is that we define the display that the Unix display that we want to show the content in, or the application in. So then refer to the actual image. And of course we can also define the resolution. If we have different devices, we can change the resolution of the app dynamically here. Then for this to work, we need to have use the host network. And then this is the most important thing to define here. So I was struggling a lot with this particularity. What happens here is that when you run Electron app, it's basically Chromium under the hood. And the way it uses shared memory, so this IPC is interprocessor communication or something like that. But basically what we are saying here that please use the host machine's shared memory concepts, so that the Chromium can then use the shared memory on the host machine in order to be able to communicate with the X11. So yeah, if you don't have this configuration, basically you will see white screen and the application will run. And also what's funny is that if you have interactive components, they can be interacted with. It just doesn't render because it renders internally then, and because there's no shared memory, the host machine doesn't know how to print that rendering out to the screen. So when we have this setting, then we actually can see the actual application. All right, and then then we share the X11 socket from the temp, so that we can actually talk with the windowing system as well. Okay, then last but not least, we have this routing that is then the internal routing on the IoT runtime. So basically what we're saying that whatever this identity gateway outputs, here we send to upstream, so basically IoT Hub. And also this is something that I haven't had time to get working yet. But basically what I then want to do is that I want to relay these messages from the serial data output into an input to the user interface. So the identity gateway has then two responsibilities. On the other hand, it sends the messages upstream into IoT Hub to store in a database or storage somewhere, and then relay those messages for the UI to use in real time. So that then kind of this is a good way of making modular systems where if you have these edge devices and you have, for example, these user interfaces, you can use the data real time on the edge. And it will work even though the network connectivity would be down. It just doesn't send upstream, but you can still use the data coming in from the serial connections with the UI application that you have deployed that is running on the edge, even without the internet connectivity. So it makes it a little bit more resilient to and less error prone. All right. And then I think that now I'm ready for my demo. I can show you the actual app. Let's see if I can just hope that I have battery left on my GoPro here. And let's hop into here. Cool, yeah, I have. So here is the my Raspberry Pi. It's 3B here in the back. And then this is the official 7-inch Raspberry Pi display, touchscreen display. And then I have an actual simulator here emulating now the well sensor. So this is just sending static values at the moment. I was just testing this setup out, and this works, but just not yet relaying the actual data into the user interface. So these are static that you can see here now. But yeah, so this is an Electron app. So you can use web technologies, you can use Grid, you can use Flexbox, you can use all the cool things in what you do in web development, and even use you can see the lines there. It's actual SVG animation here. So that's kind of cool. And then it actually is quite good and responsive. I made this quick dialog here and use CSS animations, and you can see that even though it's not hardware accelerated in any way, it's kind of quite smooth experience to make then animations and stuff. Also with this, this is just your height charts here, so you can quickly do user interfaces using standard web components and libraries with Electron. And the coolest thing is that you can then deploy that and orchestrate that from the cloud. So yeah, got my demo done already also today. So I think demo guides were more on my favor today. Last time I didn't have the demo because I couldn't deploy this. For some reason, it didn't want to start, but now it's working, luckily. So yeah. And with this, we move to the QA part of the thing. So if you have any questions now, it's a good time to ask. Oh yeah, Aquifer is pohjavesi. Thanks for that. So yeah, and if you want to follow me on Twitter, Rintsi, and Rintsi is also you can find me with that nickname on every social media from LinkedIn and so forth. If you want to follow. Yeah. Wait for questions a little bit longer, and in case nobody has anything, then we can end this live. But also the things I showed from Docker Hub and also the GitHub, I will leave the links into the description down below so you can go and see what we're actually doing. And yeah, look, I'm a proper YouTuber. I always wanted to say that. Links in the description. Now I finally did it. All right. Thanks, Joni. Looked great. All right. I think that if there are nothing to ask or no further elaborations need to be done, we conclude this live event. And yeah, feel free to ask questions also, for example, with Twitter or send me an email. I think you saw the email at some point there, rintsi@gmail.com. So yeah, thank you, and have a good one.